Our next topic is going to be U substitution. So this is going to be added to all of our integration techniques. So as far as the chain rule is concerned, and when should you use it? Well, let me remind you about the chain rule. So they don't seem related, but they really are. So if I was taking the derivative of something like e to the 3x, you have to use a chain rule because the exponent isn't just an x. As soon as it's not just an x, you got to use a chain rule. So our first function was 3x. Our second function was e to the x. So our derivative would be e to the 3x times 3. So 3e to the 3x. As far as U substitution goes, now we're looking at integration. You want to use this whenever you see something that looks like the derivative being multiplied in the problem. So use this if the derivative of something is being multiplied. And we're going to do lots of examples, but just keep in mind, this is kind of like the chain rule, but for integration. So a couple basic examples. So let's first look at this integral of 2x times x squared minus 5 to the fourth. So when I look at this problem, I'm saying, oh, it's multiplying, so I can't just do this out directly. So I got to do something else. But what I notice is that this 2x is the derivative of x squared minus 5. So whenever I notice that, I'm going to use my U substitution. So what this means is make a substitution. U is x squared minus 5. So U is going to be whatever you need it to be so that the derivative is in the problem. Then I'm going to look at du. Whenever we put du, we're talking about the derivative of u. So here's my u. The derivative is 2x dx because of the chain rule. So now that I do that, I can come over and change the problem. So this 2x right here, this 2x and this dx, those are just going to become a du, which we write at the bottom. So now I've taken care of my 2x and my dx. What's left is this x squared minus 5 to the fourth. So x squared minus 5 is u, so that becomes u to the fourth. This is a much easier problem to deal with. So u to the fourth, the antiderivative is add 1, divide by my new power, and don't forget your plus c. So we've finally taken an antiderivative, but my original problem had x's in it, not u's, so we need to go back to x's. So 1/5 x squared minus 5 to the fifth plus c. And that's going to be my final answer. We're going to do a lot more of these, but let's look at 3x squared times e to the x cubed. So like we did before, this is multiplication, so I can't just do it out directly. But what I notice is that 3x squared is the derivative of x cubed. So that leads me to think I should use U substitution, with u being x cubed. If I do that, then my du is 3x squared dx. Now I'll write the problem over here, because we have plenty of room. My 3x squared dx, that's going to become my du, so I can get rid of those two and write my du at the end. But now I have e to the x cubed. Well, x cubed is u, so that's going to be rewritten as e to the u. The antiderivative of e to the u is e to the u plus my constant c. And then my last step, go back to x's. So u was x cubed plus c. So the idea is that we're going to this other variable u so that it's easier to integrate. But u is just a stepping stone. It's not our final answer. We got to go back to x's. Okay, here's another kind of basic example. It's a little tougher than what we've done, but we're going to use U substitution. So when I look at this problem again, we're multiplying, can't do it directly. But what I also notice is that the derivative of x cubed minus 4 is really close to x squared. It's not exactly that, but it's very close. So that leads me to think u should be x cubed minus 4. So then I take the derivative. So the derivative of x cubed minus 4 is 3x squared dx. But here's the problem. I don't have a 3 in my problem. I have an x squared and I have a dx, but I don't have a 3. So what I'm going to do is divide both sides by 3, because you have to rewrite what's actually in your problem. Now that we've done that, let's rewrite it. So we said that x squared and dx, those are now 1/3 du. I'll write my 1/3 at the beginning and my du at the end. So the x squared and the dx, those got replaced by 1/3 du. That's what this second or third inequality, I guess I should say. Next I have the x cubed minus 4 to the 5th, but x cubed minus 4 was u. So that's 1/3 u to the 5th. So now this is a lot easier to integrate. Add 1, so I'll have u to the 6th as my exponent. Divide by my new power. That gives me 1/18, and let's not forget our plus c. So my final answer here, 1/18, x cubed plus 4 to the 6th plus c. Next up, let's look at x times sine of x squared plus 1. So same thing, we're multiplying, can't do this directly. But what I notice, hopefully, is that the derivative of x squared is very similar to x. So that means that u should be x squared plus 1. Then I'll take the derivative of whatever I just wrote down. So the derivative is 2x dx. But I don't have a 2 in my problem. So I need to divide by 2. So 1/2 du is x dx. Once we do that, let's go ahead and rewrite the problem. So my x and dx, those are going to become 1/2 and then du. What I have left is sine of x squared plus 1. So I can rewrite that as sine of u. And now we can take the antiderivative. So the antiderivative of sine, so think for a second, what function do I have where if I take the derivative it's sine? So it's negative cosine. Let's not forget our plus c on the end. Now that we have the antiderivative, go back to x's. So negative 1/2 cosine of x squared plus 1 plus c. Right now we're looking at sine of 2x. So I know I'm not multiplying by anything, so you might be saying, why should I use u substitution on this? But because this isn't just an x, so this is a 2x, not just an x, I need to use u substitution. So I'm going to let u be 2x. And the derivative of 2x is 2 dx. But I don't have a 2 in my problem. So I'm not multiplying by 2 in my problem, which means I need to write this as 1/2 du is dx. So I divided both sides by 2. And now we're going to rewrite it. So dx, that's going to become 1/2 du. What's left is sine of 2x, which is going to become sine of u. And now we'll take the antiderivative. So the antiderivative of sine is negative cosine, and my 1/2 is going to stay. So negative 1/2 cosine of u. And then lastly, go back to x's. So this is cosine of 2x plus c, and that would be our final answer. So this one's very similar as the last one that we did. I don't just have an x in the exponent. If this just said 2e to the x, the antiderivative would be 2e to the x, but it doesn't say that. So I'm going to have to use u substitution. So I'll let u be 8x, so that my du is 8 dx. But I do not have an 8 in the problem. What I have in the problem is a 2. So what I want to be right here is 2 dx. So to go from 8 to 2, I would divide both sides by 4. So 1/4 du is 2 dx. Now comes a time where we rewrite. So 2 dx became 1/4 du, and then e to the 8x, that's my e to the u. So my integral became 1/4 e to the u. Now I'm going to actually integrate. So the antiderivative of 1/4 e to the u is 1/4 e to the u plus c. And then we're just going to plug back in. So I get 1/4 e to the 8x plus c. It might be a good idea for you to stop and try this one on your own before I do it, but we are going to go through this. So I have x over x squared minus 1 to the 4th. So what I notice is that x squared minus 1, the derivative is 2x. Well, that's very similar to x, not exactly though. So that leads me to think I should let u be x squared minus 1, and the derivative of that is 2x dx. I definitely don't have a 2 in my problem. I do have an x and a dx though, so I'll divide both sides by 2. So 1/2 du is going to be x dx. Now we're going to rewrite this. So this x and this dx, that's going to become 1/2 du. So I'm still left with that x squared minus 1 to the 4th that was in the bottom of a fraction, which is now going to be 1 over u to the 4th. And this is kind of hard to integrate as it's written. So what I can do is I can bring that u to the 4th to the top and make it u to the negative 4. So 1/2 u to the negative 4 du. Now comes the time where we integrate. So add 1 to your exponent, that makes it negative 3. Divide by my new exponent. So that would make our new coefficient negative 1/6, and let's not forget our plus c. And then final answer, we need to go back to x's. So x squared minus 1 to the negative 3 plus c is going to be our final answer. A couple more here. In this one, I have a 5x minus 3 on the bottom. If it was just 3 over x, the antiderivative would be 3 natural log of x, but it's not just an x. So we're going to have to use u substitution. So u is 5x minus 3, which means that my du is 5 dx. So I'm just taking the derivative of u. I definitely don't have a 5 in my problem. I have a 3 in my problem, but not a 5. So I'm going to divide both sides by 5. And then we can go ahead and get rid of that 3 by multiplying both of these by 3. You always want to say, what's in my problem that I can get rid of? So in my problem, I have a 3 dx. So I want to have 3 dx equals something. Once we do that, we're going to rewrite it. So 3 dx, that's going to become 3/5 du. And then I have this 5x minus 3 on the bottom, which is 1 over u. So now we're going to take the antiderivative. So 3/5 was going to stay there. The antiderivative of 1 over u is our natural log. So 3/5 natural log of u, and then lastly go to x's. So 3/5 natural log of 5x minus 3 plus c. All right, so here we have a harder example. So for this one, maybe it's not clear what I should let u be, but parentheses almost always give it away. So I'm going to let my u be square root of x minus 1, which is really x to the 1/2 minus 1. When I do that, my du is 1/2 x to the minus 1/2 dx. Now you might be saying, I don't see an x to the minus 1/2 anywhere in my problem, but remember, x to the minus 1/2 is really 1 over the square root of x. And I do have that in my problem. It's right there. The square root of x is in the bottom of a fraction, so I do have that. But I don't have a 1/2, so I'm going to multiply both sides by 2. So I have 2 du is x to the minus 1/2 dx. So let's rewrite it. x to the minus 1/2 dx. That's going to become 2 du. So in my problem, x to the minus 1/2 is that square root of x that was on the bottom, and then there's my dx. So I've gotten rid of both of those with my 2 du. Next, I have the square root of x minus 1 squared. That was just u squared. So this is a much easier integral to deal with. So add 1 to your exponent, divide by my new exponent. So 2/3 u cubed. And then lastly, let's plug x back in. So 2/3 square root of x minus 1 cubed plus c. And here's our last one. Sine to the 8th power of x times cosine of dx. This one's maybe a little tougher because it deals with trig functions. But in this problem, let's kind of recall here, when I say sine to the 8th of x, I really mean sine of x, all raised to the 8th power. Parentheses almost always tell you what you should let u be, so my u is going to be sine x. Then my du is just the derivative, so cosine x dx. And let's rewrite it. It might be a good idea for you to try to rewrite this on your own. So when I rewrite this, cosine x dx, that's going to become just du. And then sine of x to the 8th is u to the 8th. Now let's take an antiderivative, add 1, divide by your new power, and lastly plug back in for x. So 1/9 sine to the 9th x plus c. And so those are some examples of u substitution.